We are going to start now the next lecture, lecture 4 of chapter 6 linear inequations, class 11th mathematics. So, in this lecture we will discuss a bit advanced things. We are moving from linear inequations to non-linear inequations. These are a bit advanced topics. So, the first question we have over here, it is x plus 3 into 3x minus 2 raised to power 5, 7 minus x whole cube, 5x plus 8 whole square is greater than equal to 0, and we want to solve this inequality. So, if we look at these values over here, suppose I am saying that I equate this term to 0, I am talking about x plus 3 into the next term we are talking about, it is 5x plus 8 whole square. Next we are saying it is plus 3x minus 2 raised to the power 5, and next we are saying it is 7 minus x is equal to 0. I am writing it equal to 0. Then in this case we will have the values of x is equal to 3 minus it is minus 3 minus 8 by 5, 2 by 3, and minus this is plus 7. So we are saying at these points the value of this expression, that is equal to 0. So it is greater than equal to 0 over here. It means that these are the points which satisfy this equation, and at these points the equality will hold. Now we move to the part when we are talking about that this term is greater than equal to 0. So suppose I am talking about this first point, I am plotting these points on the number line. These are the points we are saying it is minus 3, next point it is minus 8 by 5, next point it is 2 by 3, and next we are saying it is 7. Now suppose I substitute in this whole term I am talking about, this whole term we are talking about, I substitute the value of x which is less than minus 3. I am talking about I am substituting the value of x which is less than minus 3. Suppose I am substituting x is equal to minus 4. Then what will happen over here is, I am talking about these terms, it is x plus 3, then 5x plus 8 whole square, and then 3x minus 2 raised to the power 5, and then 7 minus x. These are the terms we are talking about. So one thing is clear, that whatever value of x you will substitute, this value will be positive. I am talking about these portions over here. These are the regions in which we want to solve this inequality. We are saying this is square over here, so this is always positive. Now if I am substituting, I am talking about the value x plus 3. So if I substitute the value less than minus 3, this value will be negative. If I substitute the value greater than minus 3, this value will be positive. This value will be always positive after this. Whatever value I will substitute in this portion, we are saying if I substitute the value greater than minus 3, it means I am talking about this portion over here, this is positive. For these values, this is negative. Next, suppose I am talking about the value, I have substitute, I am talking about this expression, it is 3x minus 2 raised to the power 5. So for this expression we are saying this will be negative over here, this will be negative over here, this will be negative over here. For the values less than 2 by 3, this will be negative, and for values greater than 2 by 3, this will be positive. Last we are saying the terms, I am talking about the expression 7 minus x. So in 7 minus x, if I substitute the value less than 7, I am substituting the values less than 7. In this case, suppose I am substituting the value x is equal to say 6. The answer I will obtain, it is positive. If I substitute 0, it is positive. If I substitute negative numbers, it will be positive. So all these cases it will be positive in these regions. At these points they are 0. At these points we are saying this is 0, and after this we have this portion, it is negative. So if I talk about this whole function in this region, I am talking about the value of this whole function. If the values of x are less than minus 3, we are saying these are the values we have. So the final values of this function, if we multiply all these terms, the final sign we have, that will be positive. For this region, there are plus, plus, minus and minus. In this region, the final sign we have it is negative. For this region, the final sign we have it is negative. For this region, the final sign we have it is positive, and for this region, the final sign we have it is negative. I am talking about the final sign of this term, this expression. We are saying if I substitute a value less than minus 3, this term will be negative, positive, negative, positive. So, product of all these will be positive. Next, in this portion, from minus 3 to minus 8, it will be negative. Next, in this portion, it will be negative. Next, in this portion, this will be positive. Next, in this portion, this will be negative. We require the final answer to be greater than equal to 0. So, we are having the solution set as, we are saying, we require the answer to be greater than 0. It means this portion satisfies this condition and this portion satisfies this condition. So, the final answer we will have it is minus infinity to minus 3. Minus 3 is included over here. Next, we will have this portion we are saying, this portion we are talking about, it is union closed interval 2 by 3 to 7. After this we are saying union, this point is also included, it is minus 8 by 5. So, we are saying this is the solution set in this case. So, this is one of the methods to solve this. Another method we have, it is called wavy curve method. So, in wavy curve method, what we are going to do is, we are having the expression in this form. This term, if we look at the coefficient of x, it is negative. So, to make this coefficient positive, we have written it in the form x minus 7 cube, and we have taken minus sign common over here. And because of this minus sign, this equality it has reversed. We are saying because of this minus sign, this inequality has reversed. Earlier it was greater than equal to, now it is less than equal to, and the question it transforms into this form. Our problem, it has transformed into this form. So, I am writing the transformed equation over here. It is x plus 3 into 3x minus 2 raised to the power 5 into x minus 7 cube into 5x plus 8 square, it is less than equal to 0. Again, the critical points we have, the critical point means we are talking about those values for which this expression is equal to 0. They are 3 plus 2 by 3, it is minus 3 plus 2 by 3, 7 and minus 8 by 5. Now, what we are going to do is, we are going to plot a line over here. We are going to plot the number line over here, and we have marked these points over here. This is minus 3, minus 8 by 5. These are the points we are marking over here. Next, it is 2 by 3. Next, it is 7. We have marked these points over here. Now, we are saying the values of x on this side, we are starting from this point over here. We are always considering this point to be positive because the signs of all these x we have taken, it is positive. Now, we start moving from this point and we reach the point 7. The next step we have to do is, we have to write whether these values, these powers over here, these are even or odd. We are saying the power over here, it is odd, it is 1. Over here the power, it is odd. Over here the power, it is odd. And over here the power, it is even. So, corresponding to the point minus 3, it is odd. Corresponding to 2 by 3, it is even, odd, odd and even. And when we have corresponding to 7, we have odd power. When we have odd power, we are going to cross this point. We are going to cross this point because the power corresponding to 7 we have, it is odd. Now, we reach the point 2 by 3. We reach the point 2 by 3. the power we have it is odd, so it will cross this point. It crosses the point 2 by 3. It reaches the point minus 8 by 5. The power we have it is even. It will not cross minus 8 by 5. It jumps over here. It just bounces back. It does not cross the number line over here. It bounces back and it reaches the point it is minus 3. And corresponding to minus 3 again the power it is odd. So it crosses minus 3. At this point it crosses minus 3. It reaches over here. Now look at this graph over here. What we will have is, if we look at this graph, this portion we are saying it is positive, this portion it is positive, this portion it is positive, and these portions we are saying, this portion and this portion it is negative. Now our question, it was transformed to this form, that it is less than equal to 0. So we are basically interested in this negative portions. We are basically interested in this negative portion, and because of the equality sign over here, this 8 by 5 is included. So we are saying that the solutions we have, they lie in this region, that is minus infinity to minus 3. Then 0.8 by minus 8 by 5 is there, and then we are talking about the negative portion, it lies between 2 by 3 and 7 closed interval. So these are the answers. So you can use any of these methods, you will obtain the same answer. These things will be more clear. Now the next question we have is, we have to solve this inequality, and if we look at these terms over here, the critical points we have, they are x is equal to 2 corresponding to this first term, and the power it has, it is even. Next it is minus 1 and the power it has, it is odd. Next it is 1 by 2 and the power it has, it is odd. Next it is minus 8, the power it has even. Next it is 0, the power it has even. Then it is 3, the power is odd. And next point we have it is minus 2 and the power we have it is odd. So if we plot these numbers on the number line, we are saying the numbers we have, they are 8, corresponding to this we have it is minus 8, then the next number we have it is minus 2, next it is minus 1, 0, 1 by 2, 2 and 3, and the coefficients of x we have over here, they are positive. So we start from this point over here, some positive point over here, and when we reach this point 3, we are saying the power we have it is odd, so it will cross this point and reaches the point 2. When it reaches the point 2, the power we have it is even, so it bounces back and reaches the point 1 by 2. At 1 by 2 the power is odd, so it crosses this point and reaches the point 0. Again the power is even. Then at the point minus 1 the power is odd. At the point minus 2 the power is odd, and at the point minus 8 the power is even. The next thing we have over here, it is equality sign over here. So we are saying that x can be equal to 2, minus 1, 1 by 2 and minus 8, and as denominator cannot be equal to 0, the denominator cannot be equal to 0, so we are saying that x cannot be equal to 0, 3 and minus 2. So we are saying that x can be equal to 2, x can be equal to minus 1, it can be equal to 1 by 2 and it can be equal to minus 8, but it cannot be equal to minus 2, it cannot be equal to 0 and it cannot be equal to 3. We are having these values. So we are saying that the answer we require, it is greater than equal to 0. So it will be greater than equal to 0 in this portion, then in this portion, these two portions and this portion. So the final answer we obtain, it is, we are having this minus 8 is included. So the final answer we write, it is minus infinity to minus 2, where minus 2 is not included, union, it is minus 1 to 0, 0 is not included, union 0 to 1 by 2, 1 by 2 is included, then it is union this point 2 is there, and then union 3 comma infinity. At 3, this point 3 is not included. So this is the answer, the final answer in this case. Next is fx is equal to, this is given, find intervals where fx is positive or negative. So in this case the critical points we have, it is -6, -2, 3, -1 and 5. For all these values the powers are odd. So if we plot them over here, we are saying the points we have, they are -6, then it is -2, then it is -1, 3 and 5. Now corresponding to these points we are saying we start from some positive points. At all these points the curve will pass. At all these points the curve will pass. Further, for the numerator terms, we are saying it is positive or negative. So we are considering the case that it should not be equal to 0. So we are saying none of these points it is included over here. So it is positive for the interval -6 to -2 union -1 to 3 union 5 to infinity. For this we are saying the final answer we have, it is positive. And for -infinity to -6 union -2 to -1 union 3 to 5, for these points the expression we have, it is negative. The expression we have, it is negative. So this is what we have to calculate. We have to tell the intervals for which fx is positive or negative. So for these values of x it is positive, for these values it is negative. Next is find the set of values of x for which 2x over 2x square plus 5x plus 2 is greater than 1 by x plus 1. So we can write this is 2x over 2x square plus 5x plus 2 minus 1 by x plus 1 is greater than 0. On solving these values, on solving this value, if we take the LCM over here, we obtain the final answer in this form. We obtain the final answer in this form. So if we plot the points over here, the critical points we have, it is -2 by 3, -2, -1 and -1 by 2. So the critical points we are saying it is -2, -1, -2 by 3 and -1 by 2. So we are saying that the powers we have, it is 1. So we start from a positive point over here, x is positive. We are getting the curve in this way. So the final answer we require, it should be less than 0. So we are interested in these two portions. So it is -2 to -1 open interval union -2 by 3 to -1 by 2 open interval. So we are saying the final answer is that x belongs to this interval. X belongs to values of x, they belong to this interval. Now next question, it is given that x belongs to R and we have to prove that this expression, for this expression, the value it cannot lie between 5 and 9. So suppose we are saying that the value of this expression, it is x square plus 34x minus 71 divided by x square plus 2x minus 7, this value is equal to y. So if we cross multiply these terms, we obtain it is x square plus 34x minus 71, this is equal to yx square plus 2yx minus 7y. So by adjusting these terms, we obtain it is x square into y minus 1 plus 2y minus 34 into x plus 71 minus 7y is equal to 0. Now this is a quadratic equation and it will have real roots if the value of the discriminant is 0. So the value is greater than equal to 0. So the value of discriminant we have, it is 2y minus 34 square minus 4 into y minus 1 into 71 minus 7y, they should be greater than equal to 0. So this implies us that 8y square minus 112y plus 360 is greater than equal to 0, and this implies us, if we take 8 common, we get it is y square minus 14y plus 45 is greater than equal to 0, and this implies us that y minus 9 into y minus 5 is greater than equal to 0. So, we are talking about the values of y which satisfy y minus 9 into y minus 5 is greater than equal to 0. So, clearly for these two equations, we have the critical points, they are 9 and 5, and the degree of both these it is 1. So, we are saying this is the point 5 and this is the point 9. So, if we start our line from here, this is x, y is positive, we get it is negative, then it is positive. We are talking about these two portions. So, the solution in this case, it is y belongs to the interval minus infinity to 5, it is closed at 5, union 9 comma infinity. So, we are saying what is y? Y is the value of this term, and we are saying this should lie between these two regions for the real roots to exist. So, we are saying that there is no value of y that belongs to 5 to 9, that lies between 5 and 9. Now, next we have is find all values of a for which the set of all solutions of this system is the entire number line. Entire number line means we are saying that the solution we have is x belongs to R. So, this given system, when we are talking about this system, we are talking about it is equivalent to this term. If we look at it, is x square plus ax minus 2 minus 2x square plus 2x minus 2 divided by x square minus x plus 1, and this is equivalent to x square plus ax minus 2, then it is plus 3x square minus 3x plus 3 divided by x square minus x plus 1. So, if we solve the numerator part over here, we obtain it is minus x square minus x square, then the terms with x we have it is plus x into a plus 2 and minus 4 over x square minus x plus 1, this term is less than 0, and second we are obtaining it is 4x square, then next it is plus a minus 3x plus 1 over x square minus x plus 1, this is greater than 0. So, if we take negative sign common over here, if we take negative sign, we multiply this with negative sign, we obtain this is negative, this is positive, and this inequality sign will change and this will become greater than. So, this is written over here that we are obtaining these equations in this form. Now, again if we look at the denominator over here, we are saying x square plus 1, we can write it is equal to x minus 1 by 2 square plus 3 by 4, and this is always greater than 0. So, we are saying that this system, so we can multiply this denominator on this side and we obtain that this system is equivalent to x square minus a plus 2 times x plus 4 is greater than 0, and 4x square plus a minus 3 times x plus 1 is greater than 0. And we know that if whole of this system we are saying, this whole system we are saying, it is greater than 0 from the graph of quadratic equations, we know that we are talking about this value, that the value of y that we have, it is always greater than 0, and this is the case we are saying that the discriminant is less than 0. This is the case we are saying the discriminant is less than 0. So, we are saying that this system, it is equivalent to writing b square, it is a plus 2 square minus 4ac, it is minus 16 is less than 0, and second we are saying it is a minus 3 square minus 16 is less than 0. So these equations we are saying these are equivalent to this first system we are writing, it is equivalent to x minus x plus 2 square is less than 16. Second is a it is a plus 2 square is less than 16, a minus 3 square is less than 16. This implies us this is equivalent to the system we are writing, it is mod of a plus 2 less than 4 and mod of a minus 3 is less than 4. So, we can write it is minus 4 is less than a plus 2 is less than 4, minus 4 is less than a minus 3 is less than 4. This first equation, from this first equation we are getting that minus 6 is less than a is less than 2, and from the second equation we have it is, if we subtract minus 3 we obtain it is minus 1 is less than a is less than 7. So, we are having two conditions on a. First is minus 6 is less than a is less than 2 and second is minus 1 is less than a is less than 7. So, combining these two results, the common answer we have over here is that x belongs to, the common value of a we have it is a belongs to minus 1 to 2. Next we are going to talk about the equations containing absolute values. The definitions we have it is mod of x, we know it will be equal to x if x is greater than 0 and mod x is minus x is if x is less than 0. Now, in this first case the inequation given to us it is in this form. So, we are saying it is mod of x minus 1 into mod of x minus 2, it is less than equal to 0. We can write mod x is equal to y. So, this equation becomes y minus 1 into y minus 2 is equal to 0 is less than equal to 0. To solve this equation we are writing the critical points, they are 1 and 2. So, it is always positive and this curve we get, and we are saying that it is positive over here, negative over here and positive over here. The answer we require to be negative and it is equality over here. So, both these points are included. So, what we get is that the value of y, it varies between 1 and 2. So, we obtain that 1 is less than equal to mod x is less than equal to 2. This gives us two equations, one is mod x is greater than equal to 1 or mod x is less than equal to 2. So, this first case it implies us that x is less than minus 1 or x is greater than 1, and this second case we are saying it is that minus 2 is less than equal to x is less than equal to 2, and it is and in between these two conditions. So, this gives us the final answer as, we are getting the final answer as x belongs to minus 2 to minus 1 union 1 to 2. So, this is the required solution that we have. Now, next in this question we have mod of x minus 1 over mod of x minus 2 is greater than equal to 0. Again, if we substitute mod of x is equal to y, this equation becomes x minus 1 y minus 1 over y minus 2 is greater than equal to 0. If we plot these points over here, this is 1 and 2, we are getting the, it will reach at this point like this, the answer we require to be positive. So, it is positive for, we are saying for y is less than equal to 1 and y is greater than 2, because this point is not included, it is in the denominator and this point is included. So, we obtain from these conditions we obtain that mod of x is less than equal to 1 or and we are saying mod of x is greater than 2. So, from this first condition we have minus 1 is less than equal to x is less than equal to 1, or this condition gives us minus 2 is greater than x or x is greater than 2. So, the answer we have for this case it is minus infinity to minus 2, and this is x is greater than 2 means it is 2 to infinity, and this minus 1 to 1 means it is closed interval minus 1 to 1 union. So, this is the answer we have in this case, that x belongs to these values, these intervals. Now, the next problem we have is in this form, it is mod of x minus 3 plus 4 minus x is equal to 1, and we want to find the values of x for this equality this holds. So the condition we have is that mod of x plus mod of y, in this case the value of x we have it is x minus 3, and the value of y we have it is 4 minus x. The sum of these two will be, this x and x gets cancelled, it is equal to 1 if and only if x into y is greater than equal to 0. So we are saying solving this condition, this will have a solution if x into y is greater than equal to 0. So x into y, in this case it is x minus 3 into 4 minus x is greater than equal to 0. Now to solve this inequality we are taking minus sign common to make this coefficient of x positive. We get minus of x minus 3 into x minus 4 is greater than equal to 0. It means x minus 3 into x minus 4 is less than equal to 0. So this implies us that the value of x should lie between 3 and 4. In the second part, it is mod of x plus 4 is equal to 4, and this thing holds if x into y is less than equal to 0. So we are saying in this condition we have it is x minus 4 mod, that is equal to 4 if and only if x into x plus 4 is less than equal to 0. On solving this we obtain that x belongs to the interval minus 4 to 0. If you do not want to solve by using these direct results, what we have to do is look at this first equation. The critical points we have, it is x is equal to 3 and x is equal to 4. Now if I draw the number line over here, I am talking about the points 3 and 4. Now look at the values of these functions in these regions. When we are saying that x is less than 3, then the value of, I am talking about mod of x minus 3 and mod of 4 minus x. When x is less than 3, this term we are saying, when x is less than 3, this whole term will be negative. So the answer we will have it is minus of x minus 3. When x is less than 3, this whole term will be positive. The answer we have it is 4 minus x. This whole term will be positive. If suppose I am substituting 0 over here, in place of x I am substituting 0, the answer is positive. So it means we are saying this is 4 minus x. Next is when the values lies between 3 and 4. Then this first term we are talking over here, this first term we have, this will be negative. We are saying it is positive. It is plus of x minus 3. And when the value is less than 4, we are talking about this term we are saying, when the value of x is less than 4, then this term we are saying it is again positive. We are getting it is plus 4 minus x. Next, for this next region, we will have the value of x is x minus x, mod of x minus 3 will be x minus 3, and this term will be minus of 4 minus x. Now if we add all these values, the answers we obtain, if we add these values, we get it is minus x plus 3 plus 4 minus x. The answer we get it is minus 2x plus 7. If we add these two values, this x and x gets cancelled, the answer we obtain it is 1. And if we add these values, we get it is x minus 3 minus 4 plus x. So it is 2x minus 7. So if we equate these values equal to 1, if we equate this value is equal to 1, we will get 6 is equal to 2x. So this implies us x is equal to 3. We are getting x is equal to 3. In this last case, if we equate it equal to 1, we get 2x is equal to 8. We get x is equal to 4. So we are talking about in this region, when we are considering in this portion, we are saying suppose x is less than 3, 3 and 4, these are included in this interval, and then we are talking about the region greater than 4. X is greater than 4, x belongs to the interval 3 to 4, and this is when x is less than 3. So we are saying if we are solving the equation in the region x is less than 3, the answer we are getting x is equal to 3. It means in this portion we have no solution. Similarly, for x is greater than 4, the answer we are getting x is equal to 4. So we are saying in this portion also we have no solution. And for this region, for x belongs to 3 to 4, this always holds. When x belongs to 3 to 4, this condition always holds. So we are saying that the solution of this equation is x belongs to closed interval 3 to 4, and this is what we have obtained over here. Similarly, for this case we can solve in the similar way. We are saying that if we plot these numbers on the number line, we are having the numbers over here minus 4 and 0. We are talking about the value of mod x and mod of x plus 4 in these regions. So in the first region, when it is less than minus 4, the value of this will be minus x. The value of this term will be minus of x minus 4. In the second region, we will have the value of x will be minus x and the value of this will be x plus 4. In the third region, the value will be x and this value will be x plus 4. If we add these values, we get it is minus 2x minus 4. Over here we get it is 4 and over here we get it is 2x plus 4. If we solve this equality, if we put it equal to 4, we get x is equal to 0. If we put it this is equal to 4, we get x is equal to, in this case also we get x is equal to 0. So the only solution that lies over here, it is when x belongs to the interval minus 4 to 0. This is what we have obtained over here, that x belongs to the closed interval minus 4 to 0. Only then we can have the solution. So this is how, so you can directly use these results over here, that if mod of x plus mod of y is equal to mod of x minus y, if and only if xy is less than equal to 0, and mod of x plus mod of y is equal to mod of x plus y if and only if x into y is greater than equal to 0. Now the next question we have, it is being given that the mod of x square minus 1 plus sin x is equal to mod of x square minus 1 plus mod of sin x, and we know that this condition, that mod of fx plus gx is equal to mod of fx plus mod of gx, this thing holds if and only if fx into gx is greater than equal to 0. So we are saying that if we are considering the function fx is equal to x square minus 1 and gx is equal to sin x, then from this condition fx into gx is greater than equal to 0, we are getting that x square minus 1 into sin x is greater than equal to 0, and the interval given to us, it is x belongs to minus 2 pi to pi, the closed interval we are talking about, this region. So if we want to solve this problem in this region, we are saying we are having two cases over here. First is that x square minus 1 is greater than equal to 0 and sin x is greater than equal to 0. Second, we are saying it is x square minus 1 is less than equal to 0 and sin x is less than equal to 0. Or this is one of the cases we are saying that how we can solve this. Another way to solve this is that if we look at the critical points in this case, we are saying x belongs to the interval minus pi by 2 to minus 2 pi to 2 pi. So the critical points we have from this, it is plus minus 1, and for this case we are saying we are equating sin x is equal to 0. So if we equate sin x is equal to 0, we will have the values of x is equal to, in this region we are saying it is 0, then it is pi, and then it is 2 pi, and then it is minus pi and minus 2 pi. So these are the critical points we have. So if we plot these points on the number line, we are saying we have the point 0 over here, then we have this is the point 1, this is pi, this is 2 pi, this is the point minus 1, then this is minus pi, and this is minus 2 pi. Now we are talking about the function the functions we have it is x square minus 1, and second function we are saying it is sine x. So if we look at this value x square minus 1, if we substitute the value of x to be less than minus 1 in all these regions, we are saying the answer it is positive, then it is negative in these two regions, and then it is positive for all these regions. Similarly, if we are talking about the function sine x, the answers we are saying, if we are talking about the function sine x, the answer we are saying we require the answer to lie between minus 2 pi to 2 pi. We are interested in these intervals only. So from minus pi to minus 2 pi, the answer will be positive. Then from minus pi to 0 for this whole interval, the answer we have it is negative in these two intervals, then it is positive in these two intervals, and then it is negative from pi to 2 pi. So if we talk about the product of these values, the final answer we have in this region, the answer we have it is positive, then in next it is negative, next it is positive, next it is negative, next it is positive, next it is negative. Now we require the final answer to be positive. We are saying sine x is greater than equal to 0. All these points, these are included over here. So we are interested in the interval minus 2 pi to minus pi union minus 1 to 0. All these points, these are included, union 1 to pi. So this is the final answer we obtain in this case, that the interval we have it is minus 2 pi to minus pi, then it is minus 1 to 0, and then it is 1 to pi. So we can use this kind of approach to solve these kind of problems. Next is solve mod of x over x minus 1, we are talking about mod of x over x minus 1 plus mod x is equal to x square over mod of x minus 1. So if we are considering that x over x minus 1 is equal to fx and x is equal to gx, then mod of fx plus gx, that will be equal to mod of, I think it is x over x minus 1 plus x, this is equal to mod of x plus x square minus x over x minus 1, this is equal to mod of x square over x minus 1, and this is basically the function given to us. It is x square, so you can write it as mod of x square, or you can write it as x square. So we are having again the condition that fx into gx should be greater than equal to 0. So fx into gx means we are talking about this term should be greater than equal to 0. We are saying x square over x minus 1 should be greater than equal to 0. Clearly we have x square is greater than equal to 0 for all x belongs to R. If we talk about this denominator part, it means we require the denominator part x minus 1 to be greater than 0. So we get x is greater than 1. Solution set we have over here, we are saying at 0, when we are taking x is equal to 0, the answer, this equality will hold over here, x is equal to 0. So we have the solution set as the point 0 is there, union, the interval we are talking about it is x is greater than 1, so it is the interval 1 comma infinity. So this is the interval in which the values of x lie. So this is the solution set in this case. Next is solve the equation. It is x square minus 5 mod x plus 6 is equal to 0. So we have two cases over here. Either x can be greater than 0. We are talking about two cases. First is when x is greater than equal to 0, and second when x is less than 0. In this case, the system will become x square minus 5x plus 6 is equal to 0. In this second case, we will have x square plus 5x plus 6 is equal to 0. So in this case, if we write this equation, it is x square minus 2x minus 3x plus 6 is equal to 0. So if we factorize it, we get x minus 2 into x minus 3 is equal to 0. In this case, we are getting it is x plus 2 into x plus 3 is equal to 0. So the answers we obtain over here, it is x is equal to 2 and 3. In this case, we have x is equal to minus 2 and minus 3. And these values, these are satisfying these conditions that x is less than 0 and x is greater than equal to 0. So the solutions we have, the given equation, it has the solutions in the form x1 is equal to 2, x2 is equal to 3, then x is equal to minus 2 and x is equal to minus 3. So these are the solutions in this case. Now in this next question, we have to solve this system of equation, and if we look at these terms over here, it is just equivalent to the fact. It is just the problem given over here, it is just like mod of fx is equal to minus f of x. So we are saying what this thing implies is that either fx is equal to 0, then this thing will hold, or we are saying fx is less than 0. So combining these two results, we are saying that this system is equivalent to fx is less than equal to 0. So solving this problem, it is equivalent to solving the problem x square minus 8x plus 12 divided by x square minus 10x plus 21 is less than equal to 0. Now if we factorize these terms, we obtain the numerator part, we are saying it is x square minus 2x minus 6x plus 12 divided by x square minus 3x minus 7x plus 21 is less than equal to 0. So these terms will give us x minus 2 into x minus 6 divided by x minus 3 into x minus 7 is less than equal to 0. So by using the wavy curve method, we can obtain, if we plot the line over here, we are having the critical points as 2, 3, 6, 7, and the curve starts from positive because the coefficients of x in all these terms, it is positive. So we are saying the powers are 1, so we are having the curves in this form. We are having the curve in this form. So we are interested in those values for which it is less than 0. So less than 0 means we are interested in these points over here, that is from 2 to 3 and then 6 to 7. So the solution set we have over here, it is 2, 3 union 6, 7, because this 3 and 7, they are in the denominator, so these points, these are excluded, and 2 and 6, these are numerator. So at 0, that is, we are saying for x is equal to 2, this term will become 0, for x is equal to 6, this term will become 0, and equality is there. So these 2 points, these are included. So that is why we are obtaining the intervals in this form. That is, these on the left hand side, these intervals are closed, and on right they are open. Next is solve the equation mod of x minus mod of 4 minus x minus 2x is equal to 4. Now over here, look at this function over here, it is mod of 4 minus x. First we want to remove the mod from this term. So we are considering two cases first. In the first case, we are saying, suppose mod 4 minus x, it is greater than 0. In second case, we are saying it is 4 minus x is less than 0. So when we are saying 4 minus x is greater than 0, this system will become mod of x minus 4 plus x minus 2x is equal to 4. And when we are considering it is less than 0, it will give us x plus 4 minus x minus 2x is equal to 4. X and x gets cancelled. We get it is 4 minus 2x is equal to 4. This gives us minus 2x is equal to 0. We obtain x is equal to 0. From the given condition, we have it is x is less than 4. So the solution we have in this case, it is x is equal to 0. And in the second case, in this second case, we are having mod of 2x minus 4 is equal to 2x plus 4, and the condition from this we are getting it is x is greater than 4. So if x is greater than 4, we are saying when x is greater than 4, we have 2x is greater than 8 and 2x minus 4 is greater than 4. It means this term is positive. So we are getting 2x minus 4 is equal to 2x plus 4. 2x and 2x gets cancelled. We are getting minus 4 is equal to 4, which is absurd. So we are saying there is no solution in this case. We are having no solution in this case. So the final answer we obtained is x is equal to 0. So we are saying x is equal to 0 is the unique solution of this system of equations. So we have listed some important forms containing the absolute values. So first, that we have already seen this form. It is that if the equation is of the form mod of fx plus gx is equal to mod of fx plus mod of gx, then we have seen that this is equivalent to, this system is equivalent to that fx into gx should be greater than equal to 0, and we have solved certain problems based upon these kind of situations. Now the second form we are talking over here is that the equation of the form, it is mod of fx f1x mod of fx f2x mod of fnx is equal to gx. We are saying that these are the functions of x and gx may be any constants. So to solve these kinds of problems, so we use the method of intervals, and we are saying that first of all we calculate the critical points corresponding to f1x, f2x and fnx, and if the coefficients of x is positive, then the graph starts with positive sign, and if the coefficient of x is negative, then the graph starts with the negative sign. Then using the definition of absolute value, we pass from this equation 1 to a collection of system which does not contain the absolute value symbols. So in this question it is being given that mod of x minus 1 plus mod of 7 minus x plus 2 mod of x minus 2 is equal to 4. So corresponding to these values, mod of x minus 1, 7 minus x and x minus 2, the critical points we have it is 1, 7 and 2. So if we plot these functions in these regions we are talking about, we are considering the points over here, it is 1, next it is 2 and next it is 7, and we are having three functions. First is x minus 1, next it is 7 minus x, and next it is x minus 2. So if we consider these functions in these regions, what we can see is for x minus 1 in this region it is negative, and for rest of these three regions it is positive. When we are talking about 7 minus x, it will be negative over here. For all these regions it is positive, and x minus 2 when we are talking about, for these regions it is negative and for these regions it is positive. How we are drawing these lines over here, we are saying for x minus 1 the coefficient of x is positive, so we start with positive value over here, we move up to 1 and at 1 it crosses the number line and it becomes negative. When we are talking about 7, the coefficient of x in this case it is negative, so we are starting it from the negative side, and when it reaches 7 it changes the sign over here. And for 2 we are saying we start it from positive side and it changes the sign at 2. It crosses this line we have drawn over here, the neutral line, it crosses this line and the values they become negative. So corresponding to these values we are going to write the function in the form. We are going to write it as, first case we are saying when x is less than 1. Second case we are saying when 1 is less than equal to x is less than 2. Third interval we are considering 2 is less than equal to x is less than 7. And last we have is when x is greater than equal to 7. The value of functions we will have over here, we are talking about it is x minus 1, then it is 7 minus x, then it is 2 times x minus 2. In this case also it is x minus 1, 7 minus x, 2 times x minus 2, x minus 1, 7 minus x, 2 times x minus 2, it is x minus 1, 7 minus x, 2 times x minus 2. And how we are going to put these signs over here? Look at these values we are talking about. It is minus, plus and minus. So the sign for this term it is negative, this term it is positive, this term it is negative. In the next case it is plus, plus and minus. This value is negative. Next case it is plus, plus and plus, and last case it is positive, negative and positive. So if we look at this first term over here, if we look at this first term, what is the answer we are obtaining? We are saying this is equal to 4. The equations, they are in this form and now they are free from any modulus. So the first equation will be minus x plus 1 plus 7 minus x minus 2x plus 4 is equal to 4. This 4 gets cancelled, and what we are left with is that 4x is equal to 8. This implies as x is equal to 2. But the condition we have is x is less than 1. We are having the condition over here that x is less than 1. The answer we are getting it is x is equal to 2. This thing is mentioned over here. Similarly, if you solve this second equation, you will get 1 is less than equal to x is less than 2 and x is equal to 3. When you solve this third equation, the condition we have is 2 is less than equal to x is less than 7. And the answer we are getting it is x is equal to 1. And when we solve this last equation, we will have x is greater than equal to 7 and x is equal to 4. So clearly if we look at these values, we are saying x is less than 1 and x is equal to 2. No solution. In the second case, no solution. In third case, no solution. And in fourth case, there is no value of x. So the final answer we are saying that from these four systems, the given system has no solution. There is no value of x for which this condition can hold. Now next we have to solve this inequation. So this inequation it is of the form mod of 1 minus mod x over 1 plus mod x is greater than equal to 2. So it is mod x over here. So we are considering two cases. First is if x is greater than equal to 0, and second if x is less than 0. So this system we are talking about, it will be of the form when we are saying x is greater than equal to 0. This will be 1 minus, we are talking about mod is there, x over 1 plus x. This is greater than equal to 1 by 2. And when it is less than 0, we are saying it is of the form 1 minus x over 1 minus x is greater than equal to 1 by 2. So this is equal to, it is mod over here. If we multiply these terms over here, we will obtain it is mod of 1 plus x minus x over 1 plus x is greater than equal to 1 by 2 if x is greater than equal to 0, and this is 1 minus x plus x divided by 1 minus x is greater than equal to 1 by 2 if x is less than 0. So in both these cases this x gets cancelled and we are obtaining the system in the form it is 1 over mod of 1 plus x is greater than equal to 1 by 2. 1 over mod of 1 minus x is greater than equal to 1 by 2. This is if x is greater than equal to 0. This is when x is less than 0. And this is equal to, clearly we have mod of, this term we are saying, mod of 1 plus x. This will be a positive quantity. So we can cross multiply it over here. So the answer we obtain in this case it is 2 is greater than equal to 1 plus mod x, and it is being given that x is greater than equal to 0. In the second case we are saying 2 is greater than equal to mod of 1 minus x, and it is being given that x is less than equal to 0. So in this first case we are saying x is greater than equal to 0. Look at this first condition over here. When we are saying x is greater than equal to 0, then clearly 1 plus x is greater than equal to 0. So this system, this first part we are talking over here, this first part will become, I am writing this first part over here, this will become 2 is greater than equal to 1 plus x, and it is being given that x is greater than equal to 0. In the second part we are saying x is less than equal to 0. So minus x is greater than equal to 0. So 1 minus x is greater than equal to 1. So again we are saying 1 minus x, it is a positive term. So this system, this will become 2 is greater than equal to 1 minus x, x is less than equal to 0. So we can write these equations as this is equal to, from this term we are saying that x is less than equal to 1 and x is greater than equal to 0. From this second term we are writing it is x is greater than equal to minus 1 and x is less than equal to 0. So this gives us the solution. In the first case we are saying x is less than equal to 1 and x is greater than equal to 0, it means 0 to 1 interval we are talking about. In the second case we are saying the values of x, they are satisfying, x is greater than equal to minus 1 and x is less than equal to 0. So the final solution set we have, it is minus 1 to 1. So we are saying for x belongs to minus 1 to 1, and that is this set we are saying this is the solution set, that is x belongs to minus 1 to 1. Another way to solve these kind of problems, it is, we are saying the question that was given to us, it is 1 minus mod of x over 1 plus mod x, we can, it is greater than equal to 1 by 2. So this implies us that mod of 1 plus mod x minus mod x over 1 plus mod x is greater than equal to 1 by 2. So this implies us, these two terms gets cancelled, 1 over mod of 1 plus mod x is greater than equal to 1 by 2. This term is positive, this term we are saying it is positive. So we are writing it is 2 is greater than equal to 1 plus mod x. This implies us mod x is less than equal to 1, and this implies us that x belongs to minus 1 to 1. So you can solve this problem in this way also. Next is prove that the following equations has no solutions. So the first is square root of x minus 4 is equal to minus 5. So for the real solutions, we are saying the condition we have over here, we are talking about the function square root of x minus 4 is minus 5. The condition we have is that this term should be positive, that is x minus 4 should be greater than 0. This implies us x is greater than equal to 4. We are saying x minus 4 should be greater than equal to 0 because this term is in the square root. So we are getting that x is greater than equal to 4. And for the values of x to be greater than equal to 4, the values we obtain from this, we are saying for x greater than equal to 4, the value of x minus 4 will be positive, or in place of positive we are saying it is non-negative, but the answer we have it is negative. So we are saying that it is not possible to find any value of x for which this whole value will be negative. Now in the second part, the equation we have it is square root of 6 minus x minus square root of x minus 8 is equal to 2. Again these two equations, these will be defined if 6 minus x is greater than equal to 0 and x minus 8 is greater than equal to 0. So this implies us that x is less than equal to 6 and this implies us x is greater than equal to 8. And there cannot be any common value of x for which both these equations, both these values, these are satisfied. So we are saying that this kind of equation, it will have no roots, it will have no solution. Next is we have the equation in this form, it is square root of minus 2 minus x is equal to fifth root of x minus 7. Now the conditions again we have, it is minus 2 minus x should be greater than equal to 0. So this implies us that the value of x should be less than equal to minus 2. So for x is less than minus 2, this side of the equation, the left hand side of the equation will have some solution, and we are saying that that will be non-negative. But if we substitute the value x less than equal to minus 2 in this side, we will get x minus 7 will be less than equal to minus 9. It means the value of this term will be negative. A non-negative number cannot be equal to a negative number. So we are saying that there cannot be any value of x for which this equation has any solution. So it has no solution. So this system has no solution. Next is we have square root of x plus square root of x plus 16 is equal to 3. So this equation will be defined when x is greater than equal to 0 and x plus 16 is greater than equal to 0. So this implies us that x is greater than equal to minus 16. So we are saying that the common value we have over here for these two conditions, the common value we are having that this system, the left hand side, we are saying it will have a solution when x is greater than equal to 0. Now if x is greater than equal to 0, this implies the square root of x is greater than equal to 0. X plus 16 is greater than equal to 16, which implies the square root of x plus 16 will be greater than equal to 4. So square root of x plus square root of x plus 16 will be greater than equal to 4. But in this equation, it is being given that the right hand side we have it is 3. So both these conditions, they cannot be satisfied simultaneously for any value of x. So we are saying that this system has no roots. Next is 7 root x plus 8 root minus x plus 15 by x cube is equal to 98. So from this term we are saying x should be greater than equal to 0. From this term we are saying minus x should be less than equal to 0. And from this term we are saying that x cannot be equal to 0. And all these three conditions, we are saying x is greater than equal to 0 and x is less than equal to 0. If both these conditions are satisfied, we will have x is equal to 0. But from this third condition, we are saying x is not equal to 0. So all these three conditions, they are never satisfied simultaneously. So there is this expression we are saying for real values of x, it is meaningless. So we are saying that this equation has no roots. So this kind of expression, it is meaningless. Next is some standard forms to solve irrational equations. Now the first form is, if the equation is given in the form function f is there and gx is there, so we are saying f raised to the power 2n times x is equal to g raised to the power 2n times x, n belongs to n. This system is equivalent to the system fx is equal to gx. But it is important to note over here that if we are solving this system, we are talking about, we are being given the system f raised to the power 2nx is equal to g raised to the power 2nx. We are saying this, to solve this system, we are going to solve the system fx is equal to gx. Suppose the values of x we obtain, it is x1 and x2. Now what we have to do is, we have to substitute these values in this system to verify whether they are actually roots or not. In some cases, it may happen that they are not the roots for this system. In that case, we will say that those roots, they are extraneous roots. So basically what we are saying over here is that squaring an equation may give extraneous roots. So if we have to solve this equation, we are saying square root of x is equal to x minus 2. And we square both sides of this equation. To solve this, we are going to square both sides of this equation. We get x is equal to x minus 2 square. So this implies us that x square plus 4 minus 4x is equal to x. This implies us x square minus 5x plus 4 is equal to 0. It means it is x square minus x minus 4x plus 4 is equal to 0. So this implies as x minus 1 into x minus 4 is equal to 0. So this gives us the values of x is equal to 1 and 4. Now if we substitute both these values in the equation, we substitute 1, we get it is square root of 1 is equal to 1 minus 2. We get 1 is equal to minus 1. This is not true. So we are saying this 1 is not the root of this equation. If we substitute 4 over here, we get it is square root of 4 is equal to 4 minus 2. We get 2 is equal to 2. So this 4 is the root over here. So we are saying the root of the given equation it is, the root of this equation it is 4. Now the next equation we have it is 3 times square root of x plus 3 minus square root of x minus 2 is equal to 7. So we can write it in the form 3 times square root of x plus 3 is equal to 7 plus square root of x minus 2. Now on squaring both sides of this equation, we will obtain it is 9 into x plus 3 is equal to 49 plus x minus 2 plus 14 times square root of x minus 2. So on solving this, we will obtain 8x minus 20 is equal to 14 times square root of x minus 2. So this gives us 4x minus 10 is equal to 7 times square root of x minus 2. Now if we again square this equation, we obtain it is 16x square plus 100 minus 80x, that is equal to 49 into x minus 2. Now again if we solve these equations, we will obtain the equation in the form it is 16x square minus 129x plus 198 is equal to 0. And the solution for this equation it is in the form that x is equal to 6 and x is equal to 33 by 16. And if we substitute these values, if we substitute x is equal to 6 in this equation and we substitute x is equal to 33 by 16 in this equation, we will see that x is equal to 33 by 16 does not satisfy the original equation. So the only solution we have it is x is equal to 6. Now the next form we have it is an equation of the form we are saying 2 nth root of fx that is equal to gx, and this system is equivalent to the two systems we are talking about. It is gx should be greater than equal to 0, and second we are saying is that fx is equal to g raised to the power 2n times x. So this system is given over here. We are talking about it is square root of 6 minus 4x minus x square. This is equal to x plus 4. So we are saying that this system is equivalent to x plus 4 is greater than equal to 0. This term should be greater than equal to 0. Then if this condition holds, then we are saying that 6 minus 4x minus x square is equal to x plus 4 whole square. If we solve this value, it is 6 minus 4x minus x square is equal to x square plus 16 plus 8x. This is equivalent to x square plus 6x plus 5 is equal to 0. If we solve this equation, we get it is x square plus x plus 5x plus 5 is equal to 0. We obtain x plus 1 into x plus 5 is equal to 0. This gives us x is equal to minus 1 and minus 5. From this part we are saying x is greater than equal to minus 4. So we are saying we have x is greater than equal to minus 4, and the values of x we are getting it is minus 1 and minus 5. So clearly this minus 5 is not greater than equal to minus 4. So the only solution we have over here it is x is equal to minus 1. This is the only solution we have. This is the only solution we have. Next is an equation of the form this. In place of in the previous cases, the power we have it is 1 by 2n. In this case, the power we have it is 1 by 3. So this term we are saying it is not even now, it is we are talking about odd power. So in this case we are saying if we cube both sides of the equation, we will get fx plus gx plus 3 times square root of, it is cube root of fx into gx into cube root of fx plus cube root of gx, that is equal to h cube of x. Now if we look at this term over here, we are talking about this value cube root of fx plus cube root of gx, its value is basically hx. So in place of this whole term we can write it as h of x. So we are saying that this system is equivalent to this system. So we solve this system for x, and after calculating the value we will verify whether the roots they satisfy the given system or not. So based upon this we have the problem in this form. The equation we have it is cube root of 2x minus 1 plus cube root of x minus 1 is equal to 1. So if we cube this equation, we get it is 2x minus 1 plus x minus 1 plus 3 times cube root of 2x minus 1 into x minus 1 into the next value we will have it is sum of these two values, it will be 1. We are saying the next term we are substituting from here, it will be 1, and it is equal to, we are saying it is equal to 1. So on solving this value we obtain it is equivalent to 3x minus 2 plus 3 times cube root of the values we will have over here, it is 2x square minus 3x plus 1, that is equal to 1. From this equation we are saying we obtain 3 times cube root of 2x square minus 3x plus 1 is equal to 1 plus 2 minus 3x. This is equal to 3 minus 3x. This 3 gets cancelled over here. We are left with this 1 minus x. So we obtain that 2x square minus 3x plus 1 is equal to 1 minus x cube. 1 minus x cube means we are talking about x minus 1. If we open the brackets over here, we obtain it as 1 cube minus x cube minus 3x into 1 minus x. We are having the terms over here, it is 2x square minus 3x plus 1 is equal to 1 minus x cube minus 3x plus 3x square. 1 and 1 gets cancelled. If we take x common from all these terms, we are left with this 2x minus 3 is equal to minus x square minus 3 plus 3x. So the one value of x we are obtaining, it is x is equal to 0, and what we are left over here is x square. The next term we will have over here, it is minus x is equal to 0. So this will give us x into x minus 1 is 0. So this implies us x is equal to 0 or 1. So the solutions we are getting over here, it is x is equal to 0 or 1. Now if we substitute these values in the given equation, if we substitute x is equal to 0 in the given equation, the solution will become square root cube root of minus 1 plus cube root of minus 1. The answer we have over here, it is minus 1 minus 1, that is equal to minus 2. So we are saying that x is equal to 0, it does not satisfy the given equation. If we substitute x is equal to 1, the answer we will obtain it is cube root of 1 plus cube root of 0, that is equal to 1. So it is satisfying the given equation. So the only root in this case we have it is x is equal to 1. We are saying x is equal to 1 is the only root of this given equation. Next is, if the equation is of the form this, that it is nth root of a minus fx plus nth root of b plus fx is equal to gx, then we will substitute u is equal to this term we substitute u, and this term we substitute v, and the given equations, these can be written in the form u plus v is equal to gx, and u raised to the power n plus v raised to the power n is equal to a plus b. So we are talking about the sum of these two values. So if we substitute this first term as u and this second term as v, so we are saying the values we have, it is the equations now we have, it is u minus v is equal to 1 and u square minus v square is equal to, we will have the values over here, u square is 2x square plus 5x minus 2 minus v square means minus 2x square minus 5x plus 9. If we add both these values, the answer we obtain it is 7. So we have these two equations, and from this equation we can write u minus v into u plus v is equal to 7. So we obtain u plus v is equal to 7. We substitute the value of u minus v from this equation. So we have u minus v is equal to 1. So we have 2u is equal to 8. It implies us u is equal to 4, and the value of v we get, that is equal to 3. These are the values of u and v we have. Now we have u is equal to, from the given equation we are saying that u square is equal to 16, and that is equal to, the value we have, it is 2x square plus 5x minus 2. This implies us that 2x square plus 5x minus 18 is equal to 0. The second case we are saying v square is equal to 9, that is equal to, the value of v we have, it is 2x square plus 5x minus 9. So this system is equivalent to 2x square plus 5x minus 18 is equal to 0. Both these equations, these are same. But these two equations, both these equations, these are same. So if we solve these equations, the answer we obtain is, the values of x we obtain, that is equal to 2 and minus 9 by 2. Solving these equations, we obtain this answer, and we can see that both these values, they satisfy the given equation. Both these values, x is equal to 2 and x is equal to minus 9 by 2, they satisfy these equations. So both of these, they are the solution for this equation, that is x1 is equal to 2 and x2 is equal to minus 9 by 2. Both of these are the solutions of this given equation. Now next we have is irrational inequations. So the first form we have over here, it is if the inequation is of the form that the root we are talking about, the root we have over here, it is the power is 1 by 2n, so that is this value, these are even, the root is even over here, it is fx is less than the even root of gx, then this system is equivalent to that fx is greater than equal to 0 because this term is there in this root, and we have gx is greater than fx. And if the power we have, the root we have, it is odd, then this system is equivalent to fx is less than gx. So if suppose we have to solve this problem, clearly over here the powers we have, this power it is 5, this power it is 5, so both the powers, these are odd powers. So we will obtain that this system is equivalent to 3 by x plus 1 plus 7 by x plus 2 is less than 6 by x minus 1. So 3 by x plus 1 plus 7 by x plus 2 minus 6 by x minus 1 is less than 0. So if we take the LCM over here, we will obtain it as x plus 1, x plus 2, x minus 1, 3 into x plus 2 into x minus 1 plus 7 into x plus 1 into x minus 1 minus 6 into x plus 1 into x plus 2 is less than 0. And if we multiply these terms, we open these terms, we obtain it is 4x square minus 15x minus 25 by x plus 1 into x plus 2 into x minus 1 is less than 0. So if we solve these equations, if we factorize these terms, we get it is x plus 5 by 4 into x minus 5 divided by x plus 1 into x plus 2 into x minus 1 is less than 0. So if we plot these points on the number line, the points we have it is minus 2, minus 5 by 4, minus 1, 1 and 5. And if now we draw the curve over here, all the coefficients of x, they are positive. The curve will be in this form. And the answer we require it is to be negative. So we are saying that it is negative in the interval. We look at these values over here, it is from minus infinity to 2, then minus 5 by 4 to 1, minus 5 by 4 to minus 1, and then the next interval we have it is 1 to 5. So this is the answer we obtain in this case. Next is if inequation is of the form, this thing is given over here, that it is the even root is given of fx is less than gx, then system is equivalent to, first condition we will have, because this term is in the square root, so fx is greater than equal to 0. Second condition we have is gx is greater than 0, and the third condition we have is fx is less than g raised to the power 2nx. And if the power we have it is odd, if this power we are saying it is odd, power means the root we are saying it is odd, then this system will be equivalent to this form. So based upon this we have this problem over here, this is given. So the root we have over here it is square root, so it is even, root it is even. So we can write it is equivalent to the equation that x plus 14 should be greater than equal to 0. The value of x plus 2 should be greater than 0. The value of gx should be greater than 0. And the value of x plus 14 should be less than x plus 2 square. Now this first condition gives us these three conditions. If we are saying it is x is greater than equal to minus 14, x is greater than minus 2, and this last if we solve, it is x plus 14 is less than x square plus 4 plus 2x. So we are getting over here that x square plus x minus 10 is greater than 0. So this gives us x plus 5 into x minus 2 is greater than 0. So this implies us that x is less than minus 5 and x is greater than 2. We are saying x is less than minus 5 and x is greater than 2. So if we plot these on the number line, we are saying we have the number minus 14 over here, then we have the number minus 5, then it is minus 2, and this number it is 2. Now corresponding to this first equation, we are saying x is greater than minus 14, we are talking about this region. Then x is greater than minus 2, we are talking about this portion. Then x is less than minus 5. When we are saying x is less than minus 5 and x is greater than 2, so this represents the portion. We are saying x is less than minus 5 means this portion, and x is greater than 2 means we are talking about this portion. So the common region we have, in this region we are saying, in this portion, look at this portion over here, this is the common portion to all these three equations. So the answer we obtain it is x belongs to 2 to infinity. Next is exponential equations. So if we have equation of the form a raised to the power x is equal to b, where a is greater than 0, then we have the first condition is that x belongs to phi, it is empty set, if b is less than equal to 0. We are saying this A is positive. We have some power over here. The answer cannot be negative or 0. So we are saying that if B is less than equal to 0, then there is no value of X. Second is, if B is greater than 0 and A is not equal to 1, then X is equal to log B to the base A. Third is, X belongs to phi, X is empty set, if A is equal to 1 and B is not equal to 1. And the fourth case we have is that X belongs to R, that is any real number can be answer if we are saying A is equal to 1 and B is equal to 1. So in this case we are talking about 1 raised to the power X is equal to 1. So we are saying for all X we have this answer. In this case we have the equation of the form 1 raised to the power X is equal to say 3. So we cannot have any real number X for which 1 raised to the power X is 3. So we are saying X belongs to phi, there cannot be any solution. In this case we are saying log of B to the base A is the solution. So the condition over here for this term, for the solution to be of the form X is equal to log of AB, the condition we have is that this term B should be greater than 0 and A should not be equal to 1. Now the question we have over here, the equation we have it is square root of 6 minus X into 3 raised to the power X square minus 7.2x plus 3.9 minus 9 root 3. This is equal to 0. So first condition we will obtain from this is, this term it is in square root. So the first condition we obtain from this is that 6 minus x should be greater than equal to 0. So this implies us that x should be less than equal to 6. Now we are saying if these are equal to 0, so this system is equivalent to square root of 6 minus x is equal to 0 and 3 raised to the power x square minus 7.2x plus 3.9 minus 9 root 3 is equal to 0. This gives us the value x is equal to 6. This gives us the value x is equal to 6. And if we solve this part, we are saying this is equivalent to 3 raised to the power x square minus 7.2x plus 3.9. This is equal to 3 raised to the power, this 9 we can write it is 3 square, and if we multiply it with 3 raised to power 1 by 2, the power will become 1 by 2, so it is 5 by 2, that is 2.5. So this implies us that x square minus 7.2x plus 3.9 should be equal to 2.5. This implies us x square minus 7.2x plus 1.4 should be equal to 0. Now if we solve this equation, if we solve this quadratic equation, the answers we have, it is x is equal to 1 by 5 and x is equal to 7. And if we look at these values, the condition we have over here is that x should be less than equal to 6 and x is equal to 7. So this is not satisfying this condition. So the final answers we have it is x is equal to 1 by 5 and 6. The final answer we have it is x is equal to 1 by 5 and x is equal to 6. So these are the two values which satisfy this equation. Next is 5 raised to the power x square plus 3x plus 2 is equal to 1. So we are saying that 5 raised to the power some 5 to the power some power is there and it is equal to 1. If x square plus 3x plus 2 is equal to 0, this gives us x plus 1 into x plus 2 is equal to 0. This gives us x is equal to minus 1 or minus 2. Next equation we have is 5 raised to the power 2x minus 24 into 5 raised to the power x minus 25 is equal to 0. So if we substitute 5 raised to the power x is equal to t, this will become t square minus 24t minus 25 is equal to 0. This is t minus 25 into t plus 1 is equal to 0. This is t is equal to 25 or minus 1. This sign over here, it is equal to over here, it is not equal to written. So we have these two values. Now we have 5 raised to the power x is equal to 25 or 5 raised to the power x is equal to minus 1. In this case we are saying 5 raised to the power x is never be negative number. So in this case we have no solution. And in this case we are saying 5 raised to the power 2 is equal to 25, that is equal to so this implies us that the value of x we have that is equal to 2. So x is equal to 2 is the only root of the given equation. Next is 64 into 9 raised to the power x minus 84 into 12 raised to the power x plus 27 into 16 raised to the power x is equal to 0. If we divide this equation, this whole equation by 12 raised to the power x, we obtain it is 64 into 9 by 12 raised to the power x minus 84 plus 27 into 16 by 12 raised to the power x. This is equal to 0. Why we are multiplying these terms dividing these terms with 12 raised to the power x? Because we know that 9 into 16, that is 144, and that is equal to 12 square. Look at these values over here. We are saying this 9 into 16, that is basically equal to 12 square. So that is why we are dividing this equation with 12. So the equation we are left over here, it is 64 into 3 by 4 raised to the power x minus 84 plus 27 into 4 by 3 raised to the power x is equal to 0. Now if we substitute 3 by 4 raised to the power x is equal to t, this equation becomes 64 into t plus 27 upon t minus 84 is equal to 0. So this gives us 64t square minus 84t plus 27 is equal to 0. So we are obtaining the equation in this form. Now if we solve this equation, we are talking about this equation over here. It is 64t square minus 84t plus 27. When we solve this equation, we obtain the answer in the form that t1 is equal to 3 by 4 and t2 is equal to 9 by 16. So these are the two values of t we obtain. It is 3 by 4 and 9 by 16. Now substituting these values of t in this equation, here we have substituted 3 by 4 raised to the power x is equal to t, and we are saying 3 by 4 raised to the power x is equal to 9 by 16, that is equal to 3 by 4 square. So we obtain the values of x. In this case it is 1, and the value of x in this case it is 2. So we are saying the roots of the original equation are 1 and 2. Now the next equation we have is 15 into 2 raised to the power x plus 1 plus 15 into 2 raised to the power 2 minus x is 135. So we are writing it is 15 into 2 raised to the power x plus 15 into 4 over 2 raised to the power x is equal to 135. If we substitute 2 raised to the power x is equal to t, this becomes 30t plus 60 over t is equal to 135. So this equation becomes 6t square minus 24t, this value it is 27t plus 12 is equal to 0. Now if we factorize these terms, it is 6t square minus 24t minus 3t plus 12 is equal to 0. This gives us the value of t as 4 and 1 by 2. So these calculations, these are shown over here, that we have the equation in this form and we obtain the values of t as 4 and 1 by 2. And if we compare these values over here, we obtain 2 raised to the power x is equal to 4. This implies us x is equal to 2. And 2 raised to the power x is equal to 1 by 2. This implies us x is equal to minus 1. So these are the two roots corresponding to this equation, that is x1 is equal to 2 and x2 is equal to minus 1. Next is 5 raised to the power x, and then it is 8 raised to the power x minus 1 over x is equal to 500. So we are saying we can write this 500. If we factorize this 500, we obtain it is 5 raised to the power 3 into 2 raised to the power 2. So this implies us that 5 raised to the power x over 5 raised to the power 3, that is into 2 raised to the power 2 into x minus 1 by x, 3 into x divided by 2 raised to the power 2 is equal to 1. So this implies us that 5 raised to the power x minus 3 into 2 raised to the power, it is 3x minus 3 minus 2x over x is equal to 1. So this implies us 5 raised to the power x minus 3 into 2 raised to the power x minus 3 by x is equal to 1. So this term we are saying this is basically power over here, it is x minus 3 over x. So this equation we can write it is 5 into 2 raised to the power 1 by x whole raised to the power x minus 3 is equal to 1. Now if we take log over here on both sides, we obtain x minus 3 log of 5 into 2 raised to the power 1 by x, that is equal to 0. We are talking about the log to the base 10, and we know log 1 it is 0. So we obtain from this that x minus 3 is equal to 0, or log base 10 5 into 2 raised to the power 1 by x, that is equal to 0. So this implies us x is equal to 3, or the second equation gives us 5 into 2 raised to the power 1 by x is equal to 1. So this implies us 2 raised to the power 1 by x is equal to 1 by 5. So this implies us that the value of x we have, that is minus log to the base 5 2. I think this term we are writing it is, if we take log over here, it is 1 by x log 2 is equal to log of 1 by 5. So by changing the base over here, if we take the base 5 over here, this will become minus sign over here 5, and this term will become 1. So we are obtaining the final answers in the form. The final answers we have, it is x1 is equal to 3, that is x is equal to 3, or we are saying x is equal to minus log 2 base 5. So these are the solutions of this equation. Next is we have to solve this inequality. It is 3 raised to the power x plus 2 is greater than 1 by 9 raised to the power 1 by x. So this is equivalent to 3 raised to the power x plus 2 is greater than 3 raised to the power minus 2 by x. 9 we can write it is 3 square. When we shift this upward, it will become 3 raised to the power minus 2. So we are having equation in this form. Now the base in this case we are saying we have the base over here, we have it is 3, the base we have it is 3. So what we will get is that x plus 2 is greater than minus 2 by x, because the base it is greater than 1. The base is greater than 1, so powers we can compare over here. So we get x plus 2 is greater than minus 2 by x. So on solving this, we will obtain the value of x is, if we shift this term on this side, it is x plus 2 by x plus 2 is greater than 0. So x square plus 2x plus 2 over x is greater than 0. And this numerator part, if we write, we can write it is x plus 1 whole square plus 1 by x is greater than 0. Clearly this term we are saying this is always greater than 0. So the answer we have is, this implies us that x is greater than 0. This equation it is satisfied, this inequality it is satisfied for all x greater than 0. So we are saying x belongs to the interval 0 to infinity. So this condition is important over here, that we are saying if base is greater than 1, then we can compare the powers with this inequality sign. Now next we have is 4 raised to the power 4 into 4 raised to the power x minus 4 raised to the power 2x is greater than 2 log base 4a. So if we substitute 4 raised to the power x is equal to t, this equation becomes 4t minus t square is greater than 2 into, if we look at this value 8, we can write it as 2 into 4, we can write this value as 2 into 4. So this term if we want to write it is 4, this 2 we can write it is 4 raised to power 1 by 2 into 4, so it is 4 raised to power 3 by 2. So answer for log base 4, 4 raised to the power 3 by 2, we are getting it is 3 by 2 into log 4 to the base 4. So the answer over here we have it is 3 by 2. So this inequality becomes t square, this 2 and 2 gets cancelled, t square minus 4t plus 3 is less than 0. It is t minus 1 into t minus 3, it is less than 0. So this implies us that 1 is less than t is less than 3, because the value of t we have it is greater than 0. So what is t over here now? We have substituted 4 raised to the power x is equal to t. So this implies us that 1 is less than 4 raised to the power x is less than 3. So this implies us again this base we have it is greater than 1. So we will have 0 is less than x is less than log 3 to the base 4. So we are saying that the values of x they belong to the interval 0 to log 3 to the base 4. Next is solve the inequation. This inequation is given to us. So we can write this equation, it is power 3 over here, corresponding to 3 we get it is 8 over here, corresponding to 1 we get it is 6 over here, and corresponding to this 3 we get it is 27 over here. So this equation we can write it in this form. Now look at the terms over here. We are saying this value 6 we are talking about, we are writing it is 2 into 3. So we have the terms in the form, this is 2 raised to the power 2 times x square minus 5x, this is 2 raised to the power x square minus 5x. This is 3 raised to the power x square minus 5x, this is 3 raised to the power 2 into x square minus 5x. So if we are substituting this term, 2 raised to the power x square minus 5x is fx and 3 raised to the power x square minus 5x is gx, we obtain that this function becomes 8 into f square x plus 6 fx into gx minus 27 g square x is greater than equal to 0. If we divide this equation by g square x, it becomes 8 into fx by gx whole square plus 6 into fx by gx minus 27 is greater than equal to 0. Now we substitute this fx over gx is equal to t. So equation becomes 8t square plus 6t minus 27 is greater than equal to 0. So this is x minus 3 by 2. We are saying t minus 3 by 2 into t plus 9 by 4 is greater than equal to 0. So this gives us two values of t. One is we are saying t is greater than equal to 3 by 2 and we have t is less than equal to minus 9 by 4. Now the value of t we have, if you look at this equation over here, the value of t we have it is fx over gx, it is 2 raised to the power x square minus 5x over 3 raised to the power x square minus 5x, and clearly both of these are the powers over here, so it must be greater than 0. So we are saying that t is less than minus 9 by 4. This is not possible because t is always greater than 0. Now from this equation, from this part, we obtain that 2 raised to the power, from this part we are saying that t is greater than 3 by 2, greater than equal to 3 by 2. So what we obtain is that 2 by 3 raised to the power 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 2 by 3 x square minus 5x is greater than 2 by 3 raised to the power minus 1. We're talking about this condition over here. So this implies us that x square minus 5x should be less than equal to minus 1. Why? Because this value 2 by 3, now the base, or we are saying it is 2 by 3, it is less than 1. So we are saying that this sign over here, this will be reversed. Earlier it was greater than equal to this, now it is less than equal to this. So this implies us that x square minus 5x plus 1 is less than equal to 0. And on solving this, we obtain the values of x is equal to 5 plus minus root 21 by 2. So the answers we have is that the x values, they will lie between x minus 5 minus root 21 by 2 to 5 plus square root 21 by 2. So we are saying that the final answers, they will lie in this interval. The final answers we will have, they will lie in these intervals. Next is solve this equation. So we are writing it is log base 3 5 plus 4 log base 3 x minus 1 is equal to 2. So we can write it is 5 plus 4. If we take the exponential function over here, it is log 3 x minus 1. The base over here, it is 2. So this is equivalent to 3 raised to the power 2. That is equal to 9. So we get log base 3 x minus 1 is equal to 9 minus 5 by 4. That is equal to 1. So we get x minus 1 is equal to 3 raised to the power 1. That is equal to 3. So this implies us x is equal to 4. This implies us x is equal to 4. So we are saying x is equal to 4 is the solution of this equation. Next is 2 into x raised to the power log 3 to the base 4 plus 3 raised to the power log 4 to the log x to the base 4, that is equal to 27. So one thing is clear from here, that the value of x must be greater than 0. The value of x, it must be greater than 0. So we are writing this equation in the form, it is 2 into 3 raised to the power log to the base 4x plus 3 raised to the power log x to the base 4, that is equal to 27. We are using the result that f raised to the power log g to the base a, that is equal to g to the power log f to the base a. We are using this condition over here. Now if we substitute, if we look at these values, we obtain it is this, if we add both these values, we obtain it is 3 into 3 raised to the power log x to the base 4 is equal to 3 raised to the power 3. This gets cancelled, it is 3 raised to the power 2. So we obtain that log x to the base 4 is equal to 2. So from this we are getting that x is equal to 4 raised to the power 2 is equal to 16. So we are saying that x is equal to 16 is the only root of this equation. Next is log to the base log 5x, and it is 5 over here, and this is equal to 2. Now the base of the logarithm is greater than 0 and it is not equal to 1. So we are saying that the value of log 5x should be greater than 0. We are having the condition that base of the logarithm should be greater than 0, and base of the logarithm, it can never be equal to 1. These are the two conditions we are getting from this base term, and if these two are satisfied, then from this equation we can write that log 5x is equal to 5 raised to the power 1 by 2, and this implies us that x is equal to 5 raised to the power square root of 5. We are saying this value we have, it is log to the base 5 x is equal to square root of 5. So this implies us that x is equal to 5 raised to the power square root of 5. And from these conditions, if we are talking about these conditions, we will have, from this first condition we are saying log 5x is greater than 0. This implies us that x is greater than 1. And the second condition, it is log 5x is not equal to 1. This implies us that x is not equal to 5. Now we are having three conditions over here. First is x is greater than 1, x cannot be 5, and x is equal to 5 raised to the power 1 by raised to the power square root of 5. So we are saying that this number, it satisfies both these conditions. So the only root of this equation, it is x raised to the power, x is equal to 5 raised to the power square root of 5. This is the only solution, only root of this equation. Next is 1 minus 2. It is x square over here, so we can write it as 2 log x whole square divided by log x minus 2 log x whole square is equal to 1. Now if we substitute log x is equal to t, this equation becomes 1 minus 2 into 2t square divided by t minus 2t square is equal to 1. So we are getting 1 minus 8t square is equal to t minus 2t square. So this implies us if we shift these terms on this side, we get it is 6t square plus t minus 1 is equal to 0. And from this term, we are having the condition that this term, it is t minus 2t square is not equal to 0. It means t into t minus 2 is not equal to 0. So we are saying t is not equal to 0 or 2. When we solve this equation, we obtain t is equal to minus b plus minus square root of b square minus 4ac by 2a. It is 2 into 6. So it is minus 1 plus minus 5 by 12. So the values we obtain, it is minus 6 by 12 and 4 by 12. So that is equal to minus 1 by 2 and 1 by 3. These are the values of t, and clearly none of them is 0 or 2. So we have these two values of t. Now if we substitute the values, these values of t in the given equation, we obtain in this equation we are saying log x is equal to t. So the first condition we have, it is log x is equal to minus 1 by 2. This implies us minus 2 log x is equal to 1. This implies us log x raised to the power minus 2 is equal to 1. This implies us x raised to the power minus 2 is equal to 10. So this implies us x is equal to 1 by square root of 10. So corresponding to minus 1 by 2, the value we have, it is 1 by square root of 10. Similarly, if we are writing log of x is equal to 1 by 3, we get x raised to the power 3 is equal to 10. So we get x is equal to cube root of 10. So the answers we obtain, it is x1 is equal to 1 by square root of 10 and x2 is equal to cube root of 10. These are the two roots of the original equation. So these are the two required roots.